Let's build a professional Linux security workstation using BSPWM installed manually from scratch. Most Linux desktops are designed for general users, but when you're working with multiple terminals, security tools, and lab machines, traditional desktop environments quickly become inefficient. What you really need is a lightweight, keyboard-driven workstation, a workspace that lets you control everything quickly and stay focused on the work. In this video, we're going to build exactly that, a professional Linux security workstation using BSPWM. And by the end of this video, your Linux machine will look and behave like this. On the top left, we have key network information displayed in plain sight. This includes the system's current IP address and any active VPN connection. Right next to that, there is a customizable field where we can manually define an IP address along with a label, such as main controller, server, or any device of interest. This allows us to keep important targets or systems visible at all times. In the center of the bar, we have a visual representation of 10 different virtual desktops, numbered clearly from 1 to 10. These workspaces can be switched instantly using the keyboard, providing fast navigation and an efficient workflow. The layout makes it easy to see exactly which workspace is active at any moment. On the top right, we have system monitoring and quick access tools. This includes real-time CPU usage, RAM usage, and shortcuts for opening the file manager and the wallpaper manager. Here, we can create multiple tabs and split them both horizontally and vertically, building a layout that adapts perfectly to our workflow. Everything is controlled directly from the keyboard, allowing us to move, resize, and reorganize tabs instantly without breaking focus. As we move into a new workspace, we demonstrate how tabs can be managed independently. We create new layouts, reorganize existing ones, and adjust the environment to fit a completely different task. Each desktop acts as its own dedicated workspace, while maintaining the same level of control and flexibility. In addition to managing tabs and layouts, we can also launch applications entirely through keyboard shortcuts. Tools like Firefox, Burp Suite, or any other utility can be opened instantly without touching the mouse. The goal here is not to create a flashy desktop. The goal is to build a stable, efficient, technical workstation. Also, one quick note, I already have a fully automated installation script that builds this entire environment automatically. If enough people are interested, leave a comment, and I'll upload the script to GitHub so the community can use it as well. But in this video, we're doing the manual installation, so you understand exactly how the system works. We start by updating the system and installing a couple of basic tools. You can see the commands on screen. This ensures the environment is fully up to date before installing the rest of the software. One important note, avoid running everything as root. Use sudo only when necessary. Next, we install BSPWM and SXHKD. BSPWM is the window manager. SXHKD is the hotkey daemon that allows us to define keyboard shortcuts. After installing the packages, we create the configuration directories and copy the default configuration files provided by the system. These example configs give us a clean starting point. Next, we install Terminator and PCOM. Terminator will be our main terminal environment. PCOM acts as the compositor that manages window rendering and visual behavior. Once PCOM is installed, we need to create its configuration file. Inside the config, add the following: if you're running inside a virtual machine, Xrender is the best option for stability. But if you're on a native installation with proper GPU support, you can switch the backend to GLX for smoother performance and better visuals. Next, we install Polybar. Polybar will provide our main status bar. After installation, we create the Polybar configuration directory and copy the default configuration files into it. Then, we remove the auto-generated config and launch .sh files created during installation. This ensures Polybar uses the default configuration we copied, now defined in config.ini, along with our own custom launch.sh script. Next, we create a launch script that starts Polybar. Before using the launch script, we need to make it executable. So we assign execute permissions to the launch.sh file. This allows the system to run the script properly. Now, when BSPWM starts and calls this script, Polybar will launch without any issues. Finally, we add this launch command to the BSPWM startup file, so Polybar loads automatically every time the window manager starts. Now we install Nitrogen. Nitrogen manages wallpapers. Once a wallpaper is selected, Nitrogen can restore it automatically every time the system starts. We add that restore command to BSPWM so the wallpaper is restored when the window manager loads. Next, we install CopyQ. CopyQ stores a history of copied text. This is extremely useful when working with commands, logs, or pieces of code. We add CopyQ to the BSPWM file using a simple echo command. This appends the CopyQ startup command to the configuration file. Now, every time BSPWM starts, CopyQ will launch automatically in the background, ready to manage the clipboard. We also add a shortcut for CopyQ inside the SXHKD hotkey configuration file, allowing us to open the clipboard history with a keyboard shortcut. After modifying the shortcut configuration, we reload the SXHKD daemon so the new key binding becomes active. Next, we install Nautilus. Even in a keyboard-driven environment, having a reliable graphical file manager available is still useful when working with directories and files. Next, we install Rofi. Rofi replaces traditional application menus. Instead of navigating through graphical menus, we can launch applications instantly using keyboard shortcuts. We generate the default Rofi configuration and test the launcher. Later, we will customize this much further. Finally, we configure our shell environment. We install ZSH along with several useful plugins. And then install all my ZSH. This gives us a more powerful shell with command suggestions, syntax highlighting, and a much more informative prompt. We also switch the default shell so that new terminal sessions automatically use ZSH. Earlier, I forgot to add PCOM to the startup sequence, so let's fix that now. Open the BSPWM file and add the following lines. This ensures PCOM launches automatically whenever BSPWM starts. Now the compositor will load with the system, applying transparency, shadows, and all visual effects right from login. Once all the core tools are installed, the environment becomes customizable. There are several key configuration files that control how this workstation behaves. The most important one is BSPWM. This file defines what happens when the window manager starts. Think of it as the boot sequence of your workspace. Everything that should launch automatically gets added here. Next is the SXHKD configuration file, where we define the keyboard shortcuts used to control windows, switch workspaces, and launch tools. This is where the workstation truly becomes keyboard-driven. We also modify the terminator configuration file, which defines how terminal splits and navigation behave. Because the terminal sits at the center of most technical workflows, configuring it properly is extremely important. Other configuration files, like those used by Nitrogen or Conky, mainly control visual behavior. At this point, we now have a functional technical workstation, lightweight, keyboard-driven, and optimized for working inside virtual machines. This environment will be used throughout the lab series as we explore tools and workflows related to modern security systems. In the next video, we will customize this entire environment. Right now, everything is functional. But the next step is transforming this setup into a clean, professional workstation. We will refine the layout, improve the interface, and build a workspace that looks and behaves like a high-standard technical environment. So if you want to see how to take this setup from functional to fully polished, that video is coming next, and I will see you there.